The capabilities of broadcast systems are becoming increasingly network-driven and software-defined. Soon it's conceivable that the only physical ports on some broadcast equipment will be for power and network connectivity. This leaves us with a problem. You can't see software. You also can't see the virtual input and output resources it provides. AMWA NMOS provides a simple, flexible system for registering and discovering resources within a broadcast plant. Whether you're operating a system of 2 devices or thousands in a complex routed network, AMWA NMOS registration and discovery is applicable. In this video, we'll look at an example of NMOS registration and discovery in action. We'll see how real implementations from a range of manufacturers are interoperating together today. Our demonstration setup consists of a variety of manufacturers' nodes connected using a switched network. 2 NMOS registration and discovery instances are present, operating together as a combined cluster for resilience. One instance is running as a software process hosted using compute capacity in the network switch. The other as a software process running on a normal desktop workstation. In principle, anything capable of running a web server could host a discovery and registration instance. There's nothing special about the devices in our setup. Even better, open source implementations of NMOS registration and discovery are starting to become available, meaning anyone can experiment. Also present in this demonstration setup is a manufacturer's status and routing panel implementation, which enables us to see registered NMOS nodes and make connections between their senders and receivers. Let's take a look at what is currently discoverable on the network. You can see that a sender and receiver are already active, with their presence reflected in the status monitor. This switch transceiver also contains a manufacturer's implementation of an NMOS node, so let's see what happens when it's plugged in. You can see the switch LEDs light as the transceiver boots up. And now you'll see that the node has registered its NMOS resources, and these are reflected in the status panel interface. The senders and receivers in this demonstration are all using RTP, so what we can also see is a session description protocol file for one of the senders on the network. This is a machine-readable file that is exposed by NMOS RTP senders to describe their streams. We're now going to use the routing panel interface to make connections between senders and receivers. Each time a receiver switches, it notifies the NMOS registration and discovery system with information about the sender it is subscribed to. The NMOS registration and discovery system then notifies the routing panel, which you can see is updating. Looking behind the scenes, you can see the active senders exposed by the NMOS query API, which is driving the routing panel. Finally, watch what happens when we remove the transceiver from the switch. The node it is running is automatically garbage collected by the NMOS registration and discovery system. You can see it disappear from the status monitor. If you're interested in finding out more about NMOS registration and discovery, take a look at the AMWA NMOS GitHub page. AMWA has also produced a series of videos exploring NMOS technologies in more detail on the AMWA YouTube channel.